What happens when the fire goes out, but the sub-zero temperatures don't, in a world where the power grid is just a distant, frozen memory? Imagine a desolate, snow-covered landscape stretching endlessly under the icy-colored sky, where a small campfire struggles desperately against the biting wind. Its meager warmth barely reaches your shivering body huddled nearby, trying to ward off the oppressive, life-threatening cold that promises a slow and snowy demise. This beacon of warmth, while offering instant comfort, at the same time broadcasts your exact position across the silent, unforgiving desert of snow of this new world. It acts as a super signal for any unseen dangers lurking in the shadows, perhaps even drawing the unwanted attention of shadowy figures watching from distant trees. Relying solely on an open flame for survival is a perilous gamble, as its bright light and smoke are undeniable invitations for unwanted, hostile attention. Now, let us shift our focus towards a more sustainable and stealthy solution for enduring the relentless cold, moving beyond the obvious but dangerous open flame. Consider a close-up view of several high-density basalt rocks, dark and unassuming, being carefully placed near a very robust and contained heat source. These ordinary stones are transformed into what we can properly label as our silent, smokeless thermal batteries, a truly revolutionary piece of survival technology. These awesome geological formations possess an incredibly dense molecular structure, allowing them to effectively trap and store a significant amount of heat deep within their core. They slowly radiate this stored energy outwards over an extended period, providing consistent and discrete warmth that doesn't relay your location with any light. A detailed diagram would show invisible heat waves becoming securely held within the rock's matrix, while the external environment remains shrouded in protective, silent darkness. Let's look at a compelling comparison between the short-lived nature of a flickering flame and the endurance of a glowing basalt rock. A traditional campfire, while providing an intense burst of heat, is inherently inefficient, consuming your precious and limited fuel supplies very, very rapidly. It dies out quickly, leaving you exposed once more to the biting cold and demanding constant attention and replenishment of your painfully gathered firewood and other resources. Completely opposite of this, a properly heated basalt rock continues to radiate a gentle, consistent warmth for many hours after being charged with thermal energy. It transforms into a reliable, long-lasting radiator that requires no further fuel or maintenance, offering a truly sustainable heating solution for the long night. This continuous, gentle radiation of heat from the stones ensures that your small shelter stays nice and warm for many hours at a time without giving away your position. Now that we covered the different options for staying warm, let's dive into the actual physics of why the rocks work. That's where the science of thermal storage comes into play, specifically focusing on why certain materials can hold onto heat much longer than others. When we carefully examine a generic porous river stone discovered along creek beds, we often observe a highly irregular and porous internal structure, which has a bunch of tiny air pockets and irregular voids throughout its entire composition. These natural imperfections within the stone can actually trap small amounts of water deep inside, creating a potentially hazardous situation. When such a stone is subjected to intense, sustained heat, that trapped water rapidly transforms into superheated steam. The rapid expanding creates massive internal pressures and forces that could actually lead to sudden, fragmented explosions like a natural stone grenade that explodes randomly. Now let's compare that river rock with high-density basalt, which has an incredibly tight and uniform internal structure with virtually no porous gaps or voids. This lack of empty space means there's nowhere for water to hide and explode later, making basalt the obviously safer and smarter choice for heat storage. The rock's natural integrity stays rock solid even under extreme temperatures, unlike those unpredictable river stones that could literally blow up in your face. The secret behind basalt's thermal superpowers lies in something scientists call specific heat capacity, which measures how much energy a material needs to heat up. Think of it like a battery meter inside the rock, slowly filling up as it absorbs more and more heat energy from your fire. Basalt can absorb a massive amount of thermal energy without getting dangerously hot too quickly, making it perfect for storing heat like a primitive battery. Just like your phone battery drains slowly over hours, our heated basalt gradually releases its warmth, giving you consistent heat through the coldest nights. To really understand why basalt beats other rocks, imagine subjecting different stones to rapid heating and cooling in a stress test that would destroy weaker materials. Common rocks like granite or sandstone would crack and shatter under this kind of thermal abuse, but basalt stays completely intact and ready to go. This toughness comes from its ultra-dense molecular structure, where atoms are packed incredibly tight like soldiers in formation, creating an unbreakable lattice. These tightly packed atoms vibrate with absorbed heat and transfer it efficiently throughout the entire rock, preventing dangerous hotspots that could cause cracks. Now let's talk about the charging phase, where we transform these ordinary rocks into fully loaded thermal batteries that will keep you warm all night. You'll want to place them on a sturdy metal grate over your fire or inside a well-contained heat source, using heavy gloves and tongs. Arrange the rocks so heat hits every surface evenly without overcrowding them, allowing maximum absorption while preventing any sudden temperature shocks that could damage them. This controlled heating ensures each rock becomes a perfectly charged thermal reservoir, ready to radiate warmth for hours after you pull them from the flames. Once charged, carefully transfer the rocks into your sleeping area or an insulated container lined with dry sand, using your tongs to avoid nasty burns. These hot stones will start radiating invisible infrared warmth throughout your shelter without any smoke, crackling sounds, or telltale light that could give you away. You can now sleep peacefully in complete darkness while staying warm, something impossible with a traditional fire that demands constant attention and maintenance. The real genius here is setting up a rotation system where one set of rocks charges by the fire while another set warms your shelter. This continuous cycle eliminates cold gaps and ensures you've got heat available 24/7, even when fuel runs low or you need complete stealth. While a campfire dies down to useless embers within hours, your basalt radiators keep pumping out consistent warmth well into the next morning. Beyond just heating your shelter, these thermal batteries can warm your bedding directly, transforming a freezing sleeping bag into a cozy haven from outside. You can also use them to dry wet clothes safely without risking the exposure that comes with hanging stuff near an open flame. This versatility gives you comfort, hygiene, and tactical advantage all at once, solving multiple survival problems with one simple ancient technique. The beauty of this system boils down to 3 critical advantages that could save your life in a frozen wasteland scenario. First is stealth, since there's zero smoke or light to broadcast your location to threats lurking in the darkness around you. Second is efficiency, because you're squeezing every last bit of warmth from your precious fuel instead of watching it disappear into cold air. Third is safety, since you're sleeping next to warm rocks instead of an open flame that could burn down your shelter or kill you. Picture yourself now, warm and secure in your shelter while the frozen world rages uselessly outside, unable to touch you or threaten your survival. You've mastered an ancient technique that turns simple volcanic rocks into life-saving tools, giving you complete control over your environment in impossible conditions. This is the kind of knowledge that separates those who survive from those who don't, transforming basic physics into pure practical power. By understanding thermal storage, you've turned the cold from a death sentence into just another problem you've already solved with rocks and fire. If you want more ancient survival hacks that actually work in modern emergencies, smash that subscribe button and turn on notifications right now. Drop a comment telling me which survival technique you want broken down next, because I read every single one and use them for future videos. Share this with anyone who thinks they're prepared for winter but doesn't know about exploding rocks, because that knowledge could literally save their life. Thanks for watching Sketchy Survival. Now go find yourself some basalt and stay warm out there, because winter doesn't care if you're ready or not.